In our last lesson, we learned how to find images, decide whether they were real or virtual, maximize from, so on, using ray diagrams. Today, we're going to learn how to do it using that. There are two equations. The first one is 1 over dO plus 1 over dI equals 1 over F. Second, magnification equation is SI over SO minus DI over DO. I've got to define all these variables. DO is the distance to the object. DI is the distance to the image. M is magnification. SI is size of image. SO is size of object. Note on this magnification equation, here, if SI is twice as big as SO, SI over SO is going to be 2, the magnification is 2 times. So it's going to double the size of the object. So our first example, okay, we did this example yesterday and found that the image was inverted, shrunk, and real. Specifically, I notice here that the distance to the object, we come from the center. It's about 1, 2, 3 away. So EI seems to be about 3 centimeters. We do the math, we should find the same thing. So 1 over DO plus 1 over DI is 1 half. 1 over DO is distance to the object. We did it 1, 2, 3, 4, 5, 6 away from the center. So 6 plus 1 over DI, which we're trying to find, is 1 over, and the focal length is 2. The DO is actually was given up here. Focal length is given here. So 1 over DI equals, I'm going to subtract 1/6 from both sides. So 1 half minus 1/6. 1 over DI is equal to, the common denominator is 6, at 3/6 minus 1/6, is 2/6. Now I have to take the reciprocal to get DI, so DI is 6 over 2, DI equals 3, which is exactly what we got in our ray diagram. Now for the size of the image, SI over SO is negative DI over DO. So SI, size of the object is 3 squared is tall, so the size of the object is 3, minus DI we just found out was 3, and DO was 6. So this, I get SI is minus 1.5. And our image does look like that. The minus means it's pointing downward, and the size of it, it's about 1.5 grid spaces. So our math matches our diagram very well. Okay, the next example. So, same equation, 1 over DO plus 1 over DI is 1 over F. Distance to the object this time is 3. It's 3 away from the center. So 1 over 3 plus 1 over DI is 1 over 2. The focal length is still 2. 1 over DI equals 1 half minus 1/3. Again, the common denominator is 6. So this time it's going to be 3/6 minus 2/6, so 1/6. So then DI ends up being 6. And if I look at my diagram, I start from the center and count over 1, 2, 3, 4, 5, 6. I put a little bit over 6, so it's very close. So it verifies our ray diagram, because the ray diagrams aren't going to be perfect. Then SI over SO is DI over DO, negative. So SI over size of the object is 3 again, equals minus, and DI was 6, and DO was 3. So I get the size of the image is minus 6. minus is pointing down. And again, it's not exactly right, but it's about 6. That's next example. Okay. Our distance to the object now is 1.5. So 1 over dO plus 1 over di is 1 over f. 1 over 1.5 plus 1 over di is 1 over 2. 1 over di is 1 over 2 minus 1 over 1.5. If I use 6 for a common denominator, this gives me 3/6 minus, and if I multiply by 4, 4 times 1.5 is 6, so I have 4/6 over here. So then 1 over di is negative 1/6, so di is negative 6. The negative sign means it's to the left of the center. Image is 1, 2, 3, 4. I ended up with 5 in my ray diagram. Again, it's not exactly right, but the math does verify that we're about right with our ray diagram. Si over SO is minus di over dO. Si over the object is still 3 minus, we got negative 6 here, and this was 5. If I do my math, I end up with SI plus 12 this time. Plus meaning it's pointing upward. Again, if I count it squares, it may not be exactly 12, but it certainly is a very large number. Our last example is with the concave lens and divergent lens. And I said when I introduced these way back at the beginning, the diverging lens and the concave lens, the F is negative when we use that. Because, and one way to think of it is because we're using this focus back here on the left side, and left is negative in these diagrams. 1 over dO plus 1 over di equals 1 over f. 1 over, my distance map, 6 plus 1 over di is 1 over negative 2 for the focal length. 1 over di equals negative 1/2 minus 1/6. Common denominator is 6 again, so negative 3/6 minus 1/6 is negative 4/6. So di is negative 6 over 4. Di is negative 1.5. And that's exactly where our image is showing up. Here's my center, and my image is 1.5 to the left. Now, Si over SO is negative di over dO. So Si over 3 is negative 1.5 over, make this step to 6. And if I do my algebra for this one, I end up with 3/4 for the size of the image. And if I look at my image that I have drawn here, it is about 3/4 the way up that first square. So the math should verify your ray diagram.